Okay, so we'll go in this order here. Variation is the first one there, 511, number 2 from the packet that you're working on. And that will be this one right here. So if y varies directly, remember that that equals, or that means equals k times. Those two words means k times. K is your constant of variation. All right? And it varies directly with x squared plus 2x. So if we were writing that equation, it would be y equals k times x squared plus 2x. All right, that's the first step, is to write whatever that general equation is. Now, second step is to use the information that they give you to solve for k, to determine what is the constant of variation. Here's where some people get tripped up. Remember, we would write this as f of x, which means that 5 is equal to what variable? X. Thank you. Okay. And that means that 9 is what variable? Y. All right. So 9 equals k times 5 squared plus 2 times 5. And then you solve for k. So 9 is going to equal k times 25 plus 10, which is 35. So k equals 9 35ths, and I do not believe that that could be reduced. The reason we find k is so we can rewrite the original with a k value there. That way it's just a normal function with two missing variables. So we end up with y equals 9 35ths times x squared plus 2x. Last step is to evaluate f of negative 1, which means we're just taking this equation and doing what? Substituting negative 1 for x, solving for y. So that simplifies to negative 9 35ths. So when next one here, we're doing number 3. So we got to rewrite that f of x there in a hyperbola form rather than just rational form. So remember, when we start that process, the first step is always the same. Can't write. First step is always to take whatever the denominator is and just put it in the numerator. So we put an x plus 2 in the numerator. Okay, and then we need to try to determine what to do to that x plus 2 so that it still equals 2x plus 5. There's an easy way, or a shorter way I should say, and then there's a way that takes multiple steps. So if I'm using the shorter way, what would I want to do to make x plus 2 still equal 2x plus 5? Kirsten? I want to multiply by 2. If I multiply everything by 2, that's fine. 2 times x is 2x, but 2 times 2 is 4. I don't want 4, I want 5, which means I have to add 1. All right. Once I do that, or once I figure that out, now I divide both of these by x plus 2. So I end up with 2x plus 2 over x plus 2 plus 1 over x plus 2. Advantage is that the x plus 2's cancel each other out, and we're left with just 1 over x plus 2 plus 2. Which from that equation we can determine what our shifts are. So we have a left 2 and we have an up 2. So if I was graphing that hyperbola, left 2, up 2, sketch the graph. Much easier than sketching it from this particular point. Okay? Just a bonus here for all of us, conceptually, if x is going to infinity, all right, if x is going to infinity, what is the limit as x approaches infinity? What is the y value approaching? Shane? 2. Very good. explanation here is that if x is infinity, that means the denominator is a really, 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 really huge number. Anytime we take a number divided by a really huge number, we get 0. 0 plus 2 is 2. Okay, same if it was negative infinity. All right, anything divided by negative infinity is also 0. Or at least it equals a really, really small number. So close to 0, we can't tell the difference. 2 plus 0 is 2. Okay, that's sort of the way you think about it if you don't have a graph. Although we do have a graph, so we could just look as it goes to infinity. As it goes to negative infinity, it's approaching that horizontal asymptote. That's just a little bit of a bonus there with that problem. An advantage of having it written like this as opposed to this, unless you know some shortcuts from calculus. Okay? All right, when graphing a reciprocal, if they give you this equation, we're looking for some certain points in particular to start. We're looking for the x-intercepts, just the x-intercepts. Because at the x-intercepts, y equals 0. 1 over 0 is undefined. So on the reciprocal, that will yield a vertical asymptote. Because dividing by 0 is undefined at this point. Once you have your VAs, then you're just looking at each section of the graph. Okay? And in this section, as I'm leaving the x-intercept, my y values are getting bigger. If I take the reciprocal of that, they're not going to get bigger, they're going to get closer to 0. As I'm going towards the x-intercept, my y values are getting smaller. 1 over small equals big. So as I go towards the intercept, they go to infinity. Of course, you could always just memorize the pattern, that if it's linear, it ends up becoming or looking just like a hyperbola. Same thing over here. Leaving the intercept, I'm getting bigger. 1 over big equals small. Coming towards the intercept, I'm getting smaller or closer to 0. 1 over small equals big. Same rule applies for the middle section. As I'm going towards the intercept, I'm getting smaller. If I flip that, going towards the intercept, I'm going to get bigger. Same thing this direction. Smaller, 1 over small equals big. Okay? That's sort of the concept behind it. Of course, almost all of them that we've done to this point are similar, which means you could always just memorize the pattern. One thing you need to remember, that if the original graph, one small rule here is that if the original graph is positive, that means the reciprocal is going to be positive. When you take the reciprocal of a number, it does not make the number negative or positive. It only changes the fraction. It flips the fraction. If it's positive, it stays positive. Negative stays negative. Might be a nice little note to jot down on your study sheet for when you get to that problem. Doesn't matter. Oh, it was number 3? Okay, so number 3 here, evaluating a limit using a table. Let f of x be x cubed minus 8 over x minus 2. Complete the table of values to estimate the value of the limit as x approaches 2. Okay, this is just about using the calculator. Can you use the calculator to determine what these particular values are? So you just got to go into table, table set. Okay, table start will be whatever you're approaching, in this case 2. And then delta table is what you change each time. So delta table, if you count by 0.1 first, that'll give you 2.1 and 1.9. And then you change delta table to 0.01 and then 0.001. You'll be able to fill in all those values. So if I use my calculator to determine these table values here, remember, just keep going to table start. Keep changing delta table, 0.1, 0.01, 0.001. Fill in the table. I can see that coming from the right, coming from the positive direction, I'm obviously getting closer to 12. On 12.6, 12.06, 12.006. Okay? Coming from the left, 11.41, 11.94, 11.994. I'm also approaching 12. So the best assessment here of the limit of that function, f of x, as x approaches 2, would be 12. Okay? And that could be a different answer every time. It's all about being able to use the table function on your calculator the way you need to be able to use it. This one will be tough by hand or using a graph because this isn't going to show up on your graph. 12 is off of your normal Zoom standard window. So it'd be really difficult to find where that hole is. All right, using the table is going to be the best option. So look at the word problem here. Maximum weight, M, that can be supported by a beam is directly proportional to its width, W, and the square of its height, H. It is inversely proportional to its length. So we have a lot of things going on here. First of all, we're talking about weight M. So it's going to be M equals, all right, and it says directly proportional. That means varies directly. That means K times its width, W, and the square of the height. So that'd be H squared. And then we have a second sentence here. Inversely. It is inversely proportional. That means divided by the length L. You can only have one general equation to be able to do these. A lot of people are tempted to write two equations. We don't want to write two equations. We got to have everything in one equation. Now, it's asking us to determine the constant of proportionality. That's K. If the beam is 4 inches wide, W, 6 inches high, H, and 12 feet long, L, and it can support 7,400 pounds. Okay? So if I do that, let me see here. So if I take a look at that, I'm going to substitute each of those values in for what I know. So I have 7,400 equals K times W, which is 4, times H squared, 6 squared, divided by L, which is 12. And then I just simplify. So 7,400 equals 36 times 4 divided by 12. Okay. So that's going to be K times 36 divided by 12 is just 3, right? So 4 times 3 is 12. So K times 12. Divide both sides by 12. Okay. So K ends up equaling, let me get there, 5, 20 is 1, so it's 51, 500, no, 50. Anybody? Some help there? 7,400 divided by 12. 6. Oops. Yeah, 6, 16, 2/3. Sorry about that. Yeah, I was thinking 65 is 60, not 72. So 6, 16, and 2/3. Okay. Then, so knowing that, we would substitute that in just for K. Okay. Everything else stays the same. But then it asks us a question. If the beam is 10 feet long, 3 inches wide, 10 inches high, what's the maximum weight that it can support? So we would substitute each of those values in. So we would have, let's see here, M equals 6, 16, and 2/3 times a width of 3 times a height of 10 squared divided by a length of 10 feet. And then that would give us the maximum weight it could support. So it's a little shorter, it's not as wide, and twice as high. I'm assuming the weight's going to go up significantly that it can support. That's just a guess. Anybody? Times 3 times squared, what's that? Divided by 10, and I was right, 18,500 pounds. Okay?